Today we'll be looking at how to add propellants to Romans and to analyze their thermochemical properties. So just click on Pyrogen, then tab, and then click Propellants. It comes with a bunch of propellants already included. We'll just add one to show you how it works. Another version of black powder. Standard black powder description. We'll use it as a propellant and a pyrogen. Then go down to the chemicals grid and type in the chemicals you want to include. So it'll be potassium. Hit the F4 key or press on that tab to bring up the list. So potassium nitrate, 75%, charcoal, maple will do, I guess, 15, and sulfur is 10%. You can add in any instructions you want. Then click onto the burn rate results screen, and this little calculator here will now analyze, once it's pressed, it'll analyze all those chemicals and fill in these results such as the density, characteristic, velocity, chamber temperature, etc. The two that it won't do is the burn rate coefficient and burn rate exponent. They have to be gotten by actually performing tests on it. You can calculate it, and I'll show you how to do that shortly. So if we click on the calculator tab, and we can have a look at the output files. You notice it's filled in all these values now, so it's analyzed it. We'll have a look to see what the analysis is. So it comes up with all the chemicals. It'll show you the pressure of the chamber throat and exit, and all these things are such as entropy, internal energy, and Gibbs free energy, and all that sort of thing. Useful if you're a chemist, I guess. Down here you'll see all the products that are produced. These are all the gases. So there's 57 grams of gases produced, and these are all condensates, liquids. And there's 42 grams of condensates produced. So we'll close that, and we'll save that. To work out these burn rate coefficients and burn rate exponents, as I said, you need the actual burn rates for different pressures. So we'll just look at this one here, black powder. We've got some values in here that I got from from a PDF file that I found on the internet. So we'll just zero out these values so you can show that it's actually calculated, and select the results that you want to use within the calculation. So I've selected all of those. You see at different pressures you get different burn rates. You can go calculate. We won't look at the output file, and it's calculated the coefficient and burn rate exponent, and you can say save that. You can also use things like mixtures. For instance, there's this is a standard rocket candy, but it's using a corn syrup, Caro corn syrup. Now, Caro corn syrup is actually a mixture itself. So if we look at go into mixtures, you can add mixtures, provided you know what's actually in the mixture. You can add them and then use those mixtures within the propellants or delay grains and pyrogens, and you can perform chemical analysis on those. We'll have a look at corn syrup and see what's in that. Once again, I got this information from the net. If you just search, you'll find things all over the place. So corn syrup typically has dextrose, maltose, water, and starch. So if you want to add that, you go into there, into your propellants, click on that, and you'll see corn syrup there. Let's just add one. We'll add, let's go into mixtures again. Ping pong balls. Okay, so ping pong balls are made from celluloid, and it's made from nitrocellulose and camphor. Now these chemicals are actually, if you look at the chemicals button, if you go into chemical screen, all the chemicals that you require must be in here. So let's see if camphor's in here. Camphor's not. So we can add it. It's really easy to add. Once again, look up the net. You'll find the chemical formula for camphor and heater formation and density. These are the things you need. So you can just add it. Camphor. It's 10 carbon, 16 hydrogen, and 1 oxygen. Its heat of formation is 319 kilojoules per mole, and density is 0.992 grams per cubic centimeter. So we save that. Now we go back into mixtures. Just need to update that. And click on camphor, and there it is. So now we can use those ping pong balls in chemical analysis. So if we go into pyrogens, you'll see NC lacquer. That has ping pong balls in it. Go to the burn rate results, click on the calculator, and what it does is looks at that mixture ping pong balls and gets the chemicals that are actually in the ping pong balls, which is nitrocellulose and camphor, and does the analysis on that accordingly. So it's very useful, very easy to use, and once you've added your particular propellant, you can then use it within the burn rate simulator, motor burn rate simulator, which I'll show you in another video. Okay, thank you for watching.